Points x, 1, 1, and y, 5, 5, are plotted on a coordinate plane. Find the distance between points x and y. Find the exact value and the approximate value to the nearest tenth. So our first step is to plot the points on the graph. Here we have point x at 1, 1. And here we have point y at 5, 5. Next, we need to draw the segment that connects them. Now, if we plot a point here, we can drop down a line here so we can form our triangle. So let's plot a point Z right there. This will form the third vertex of our triangle. So here we have side XZ, and here we have side YZ to form a right triangle. If I find the length of XZ and YZ, then I can use the Pythagorean Theorem to find XY. To find the value of the length of XZ, we have to take the absolute value of the distance between the two points X and Z. So XZ equals the absolute value of 5 minus 1, which equals a total of 4 units. And then I need to find the length of YZ. And I have a y coordinate of 5 and 1. So for both of these, the distance of the legs are 4 units. Now that I have my two side lengths, I have this is 4 units, and this is 4 units. So I can use my Pythagorean Theorem, which is a squared plus b squared equals c squared. So I have my one side that's x, z, and I have my other leg that is y, z, and my hypotenuse is x, y. I know my side lengths for both x, z, and y, z are 4. So I can plug those right into my equation. So we know that 4 squared is 16. So I have 16 plus 16 equals xy squared. Next I have to do 16 plus 16, which is 32. So I have 32 equals xy squared. Now again, remember, you're not done. You still have this square, and the opposite of a square is a square root, so you have to take the square root of both sides. The square root of 32 is approximately 5.7 units. So there should be an approximate sign, sorry. So your exact answer, would be the square root of 32, and your approximate is 5.7